Welcome. This is the SBAC test review packet solution for chapter 2, which is on page 2. We are going to go over questions 5, 6, 7. Okay, what you have here is question 5. I already have the answer displayed to you because I have to show you how I get it. So just please listen to the explanation so you can learn, okay? Alright, so we have here a trapezoid is undergoing a series of transformations. That's mean a couple. Describe the three basic transformations that can show the two trapezoids are similar to each other. In your response, be sure to identify the transformations in the order they were performed. So you have A, B, C, D, that's the trapezoid, and you want to go to A prime, B prime, C prime, and D prime. First of all, I'm going to translate it one unit up. So watch this, it's going to go up. Let's grab that. It's going to go up one. Okay, good. Do you see how it went up one? Then it's going to go to the right one. So we match the corner, so the letter D went to the letter D prime by the first translation and the second translation. Right? From here, we dilate it by a scale factor of 2. Why do we dilate it by a scale factor of 2? Look at the length here. The length of AB is the value of 2. Then the length of A prime and B prime is 4. 1, 2, 3, 4. So from the number 2 to the 4, we multiply it by 2. There you go. So we dilate it by a scale factor of 2 to get it. There it is. We would say that the two objects are similar because they have the same shape but different size. Okay, that is the definition of similar. Alright? That is how you figure out your solution for number 5. Let's look at number 6 now. Okay? Consider the figure here. Determine if the statements are true, false about the sequence of transformations that can verify that triangle PQR is congruent to triangle P prime, Q prime, and R prime. Alright? So, these are already the answers, but I'm going to show you how I got it. Alright? Okay. I want to make sure you can see this, okay? Alright, so the first one, triangle PQR is translated 9 units down, then translated 9 units to the right. So here's the triangle, and it says 9 units down, so let's slide it 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 units down, then 9 units to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. I followed that exactly. Is it right on top of each other? No. So this is why it's false. So let me just bring it back to its original spot. Next, you want to have this triangle, then you want to reflect it over the x-axis. So reflect it over the x-axis, it will look like this. Okay, right there. Okay, goes from here, reflect it over here. Remember, when you reflect it, it has the same distance from that axis. So P to P prime, R to R prime, Q to Q prime. No, is this right? Is this right? Looks like it should be. Hold on, this should be. I need to flip this. I have to flip this somehow. It's not right. I have to flip it somehow. Give me a second. Let's see if I could flip it. No. Where is it? I gotta flip this because when it because it's like here, then it flips. It looks like this when it flips. Oops. This doesn't look right. Let me grab this. Can I flip it? If not, I might have to just draw it. Okay. I gotta draw it again. I can't flip it. So let me just insert the image here. When you flip it, it's right here. It should go right here. P. This is P R Q. Close it. And let me just do a non-fill right here. So this is what it looks like when you flip it over the x-axis. Then you want to translate it 9 units to the right. So you want to grab this, move it to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, it's right on top of each other. So you would say that that is true. Okay. And last one. What have if we have here, you want to rotate it 100 degrees clockwise above the origin, then translate it 2 units to the right. If you rotate it 180 degrees clockwise, let's grab the triangle, rotate it. This would be 90 degrees. That would be 90 degrees, then rotate it again. Right? This would be what the triangle looks like after the 180 degree rotation. Then you want to go 2 units to the right. Grab this. 1, 2. There you go. That would be your answer. Okay? So that is also false because it's not right on top of each other. The only one that when you transform the object, it's right on top of each other is the second one, which is the only one which is true. Alright, let's go. Let me delete this. Oh. Okay, let's do this one. Right, here's your parallelogram. Number 7. The parallelogram ABCD is rotated 90 degrees counterclockwise above the origin, then translated 2 units down, then 4 units down to form parallelogram A prime, B prime, C prime, and D prime. What is the length in units of the line segment A prime, B prime? So we have the original quadrilateral or parallelogram of A, B, C, D. We have to rotate this 90 degrees counterclockwise. So it's going to rotate here, right? Let's see. It should rotate here. That's off a little bit. Okay, that's what it looks like after the 90 degrees counterclockwise rotation. Then it is 2 units to the right. 1, 2. Then 2 units, then 4 units down. 1, 2, 3, 4. Okay. Now, they say what is the length of A prime and B prime, right? Notice that I actually didn't have to do the transformation because, let's read this. I would say that AB, the line AB has 4 units. How do I know? Just count it. Look. 1, 2, 3, 4. Right? So AB has a length of 4 units. A prime and B prime, that length is also 4 units. Why? Listen up. Because rotation and translations are rigid transformations. That is the definition. What are rigid transformations? They do not change the shape or size. This was a quadrilateral that did not change shape or size. It is also a parallelogram that did not change in shape or size. Okay? The rotation and the translation did not change its shape or size. Hence, or therefore, the object has the same length before and after the transformation. The fact that it had a length of 4 before, it has also a length of 4 after, because rotation and translation did not change its shape or size. Good? This is part definition and conceptual. you have to understand that rotating and translating does not change the object's length or size. So if it's for before, it's also for after. The before and after object are always congruent. Right? So there you go. That is your answer for number 7. So there you go. Those are all your solution for page 2 for your SBAC test review packet.